This week, NASA announced the postponement of the Artemis II and Artemis III missions until 2026 and 2027, respectively. Artemis II was to send a 4-person crew, 3 Americans and 1 Canadian, on a lunar flyby of the moon. Artemis III is to be a lunar landing to return people to the moon for the first time since the December 1972's Apollo 17 mission. The stated reason for the delay was the excessive and uneven wearing of the ablative heat shield on the Orion crew capsule during the unmanned Artemis I mission. As disappointing as the delays are for NASA, the greater concern is the future of the Space Launch System, or SLS, in future budgets. Despite the delay of the Artemis II mission from September 2025 to April 2026, the Kennedy Space Center is currently stacking the SLS. The goal will be to use the extra time to do integration testing between SLS and the Orion capsule. SLS has had one successful launch, Artemis I, but has a history of cost overruns for a program that was to use proven technologies from the space shuttle to save costs. The SLS utilizes RS-25 rocket engines as its primary engines, which were also the primary engines on the space shuttle. These engines utilize a blend of liquid oxygen, LOX, and liquid hydrogen, LH2, as their fuel. Unlike the space shuttle, which reused the RS-25 engines, the SLS lacks reusability, and the RS-25's exclusive use for SLS launches represents a regression in terms of reusability. The SLS also uses solid rocket boosters, SRBs, which utilize previous shuttle boosters and incorporate an additional middle section to enhance their performance compared to the space shuttle's SRB versions. Again, the difference lies in the fact that the SRBs for the SLS, unlike those for the space shuttle, are not recoverable and, once expended, crash into the ocean. NASA's most powerful rocket, the SLS, is the only human-rated rocket capable of sending the Orion capsule to the moon, producing 8.8 million pounds of thrust in its current Block 1 configuration, compared to the Saturn V's 7.5 million pounds of thrust used for moon missions. The lack of reusability and other delays in the SLS have resulted in cost overruns, with the rocket costing an astounding $2.6 billion per launch and an additional $1.5 billion for the remaining mission, totaling $4.1 billion per Artemis mission. For a rocket based on existing technologies, this outcome was unexpected. The SpaceX Starship and Super Heavy booster create 17 million pounds of thrust in the current configuration and will eventually cost $10 million per launch. The projected savings stem from the reusability of both the SpaceX Starship and Super Heavy, in contrast to the SLS, which lacks reusability, and only partial reusability of the Orion capsule atop the SLS. The incoming Trump administration is expected to make large budget cuts, with SpaceX's Elon Musk making recommendations on areas to cut the federal budget, so it appears it could be a conflict of interest for Musk to make the recommendation to cut SLS. This statement appears to be accurate, and Vivek Ramaswamy, who is also a member of the same committee as Musk, could potentially address this issue with NASA and SLS to avoid the conflict of interest concerns. From a pure cost perspective, choosing SpaceX's Starship program, which costs $10 million per launch instead of $2.4 billion, is a logical choice. However, it's important to keep in mind that SLS is no longer an experimental program and is a rocket rated for human use. Its cost per launch is well established. The Starship and Super Heavy are still in the experimental phase and undergoing testing, so the projected cost of $10 million per launch remains aspirational and not yet a reality. SLS is also capable of launching Orion to the moon in a single launch, but once in orbit, the Starship would require refueling, necessitating at least one additional launch of a refueling Starship and probably more. Additionally, landing on the moon would require the use of a lunar version of Starship. Transporting the crew to the moon requires multiple launches of a single Starship. Additionally, a lunar version of the Starship will transport the crew to the surface and return them to lunar orbit, where they will return to Earth on the same Starship that transported them to the moon. Even with all these multiple launches, if the Starship manages to meet the $10 million per launch goal, it could launch 240 missions before it reaches the cost of launching a single SLS. The cost savings of the fully reusable Starship and Super Heavy start making a difference. We also need to include the approximately $70 million manufacturing cost of the combination in the cost savings calculations. Multiple launches could potentially increase the mission costs for an Artemis mission by $1.5 billion, in addition to the cost of Starship, Super Heavy, and the Lunar Starship. The Chinese have stated they expect to land a man on the moon by 2030. If SLS is scrapped due to its cost, could the US still beat the Chinese to the moon if that is the national priority? SLS's $23 billion development and the Orion space capsule's ongoing $20 billion development would become sunk costs. There is currently no other human-rated rocket that can send the Orion capsule to the moon like SLS. Should we decide to scrap SLS but continue with Orion, there exist potential options. SpaceX's Falcon Heavy and Blue Origin's New Glenn are potential commercial options, but neither is rated for human spaceflight, and both would need to be heavily modified to support the Orion spacecraft. While the DOGE Task Force's recommendations are not legally binding, it is evident that the SLS's economic viability pales in comparison to commercial options. The decision that the incoming Trump administration will need to make is whether they want to beat the Chinese to the moon as a national priority. Or does the Trump administration prefer to cut costs by canceling the entire program and shifting the responsibility to commercial companies who seem capable of achieving the same goal at a lower cost than NASA's SLS, but are unlikely to be prepared to beat China to the moon? The most likely stark choice is to attempt to beat the Chinese to the moon or save money and forego a space race with China.